Let's talk about stars, not the kind that walk red carpets, but the true giants that illuminate the vastness of our universe. These cosmic beacons have fascinated humans for millennia, inspiring myths, guiding explorers, and fueling our curiosity about what lies beyond our world. Among the billions of stars scattered across the Milky Way, a few stand out as true titans. These are the stars that shape galaxies, create elements, and sometimes end their lives in spectacular explosions that can outshine entire galaxies for a brief moment. High in Orion's shoulder sits Betelgeuse, a red supergiant that's captivated humanity for centuries. Ancient civilizations charted its position, weaving it into legends and stories that have survived to this day. Its fiery orange-red glow makes it one of the brightest, most recognizable stars in our sky. On a clear night you can spot Betelgeuse with the naked eye, its distinct color setting it apart from the sea of white and blue stars. If Betelgeuse replaced our Sun, its surface would stretch past Mars, swallowing Mercury, Venus, Earth, and the asteroid belt, reaching Jupiter's orbit. Imagine our solar system engulfed by a single colossal star, its outer layers extending far beyond where our planet orbits today. Our Sun would be a mere speck beside it. Betelgeuse is so immense that if it were placed at the center of our solar system it would dwarf every planet, making even mighty Jupiter seem insignificant. Betelgeuse shines with the power of 100,000 suns burning through its fuel at a breakneck pace. This incredible energy output is both awe-inspiring and a sign of its impending fate. It's nearing the end of its life, on the verge of a spectacular supernova. Betelgeuse pulses and shifts, its outer layers expanding and contracting as it prepares for its final dramatic act. Scientists study Betelgeuse closely, as it offers a rare up-close look at the death throes of a massive star. Every flicker and dimming event is a clue, helping astronomers piece together the mysteries of stellar evolution. Observing it helps us understand how stars live, die, and seed the universe with elements essential for life. When Betelgeuse finally explodes, it will scatter heavy elements, like carbon, oxygen, and iron, across space, enriching future generations of stars and planets. Betelgeuse is more than a point of light, it's a cosmic laboratory and a source of endless wonder. Its turbulent surface, swirling with hot gas and dust, offers a glimpse into the powerful forces that shape our universe. At just 500 to 600 light-years away, it's close enough for detailed study, yet far enough to be safe when it finally explodes. This proximity allows astronomers to monitor its every move, capturing data that could one day help us predict supernovae in other galaxies. For thousands of years, Betelgeuse has been a fixture in our night sky, a silent witness to the rise and fall of civilizations. Its story is woven into our own, connecting us to the cosmos in ways both scientific and deeply human. Watching Betelgeuse is like witnessing a cosmic drama unfold in slow motion, a reminder that even the mightiest stars have their time to shine and their time to fade. For centuries, Betelgeuse was a steady beacon in the night sky, a familiar red point marking the shoulder of Orion. Ancient civilizations tracked its glow, and astronomers relied on its constancy to map the heavens. Its brightness was so reliable that any change would have seemed unthinkable. Until late 2019, when something extraordinary happened. Betelgeuse began to fade dramatically, puzzling both amateur stargazers and professional astronomers alike. Over just a few months, the star lost nearly 2/3 of its brightness. This mysterious event quickly became known as the Great Dimming, and it was unlike anything ever recorded for a star of this kind. The world buzzed with speculation. Was Betelgeuse about to explode in a spectacular supernova? Social media and news outlets were filled with excitement and concern as people wondered if we were witnessing the end of a star in real time. Telescopes worldwide, including the legendary Hubble Space Telescope, turned their gaze toward Betelgeuse. Teams of scientists scrambled to collect as much data as possible, hoping to solve the mystery before the star changed again. The truth, when it emerged, was even stranger than the rumors. Betelgeuse had ejected a massive chunk of its own surface, launching a colossal cloud of plasma into the surrounding space, a stellar outburst on a scale rarely seen. This eruption was hundreds of billions of times more powerful than anything our Sun has ever produced. The sheer energy released was almost beyond comprehension, dwarfing even the most violent solar flares. As the ejected material cooled, it condensed into a thick dust cloud. This cloud drifted between Betelgeuse and Earth, blocking much of the star's light and making it appear to dim from our perspective. The star itself hadn't actually faded or died, Our view was simply obscured by its own cosmic outburst, a veil of dust hiding its true brilliance. This unprecedented tantrum forced scientists to rethink what they knew about red supergiants. It revealed that these stars can shed huge amounts of material in their final years, rewriting our understanding of how they behave before their ultimate fate. Betelgeuse's great dimming was more than just a spectacle. It was a cosmic drama that reminded us how dynamic and unpredictable the universe can be, even in the stars we think we know best. Betelgeuse's surface isn't solid, it's a churning sea of hot gas, constantly in motion and shaped by powerful forces deep within the star. Unlike planets or smaller stars, Betelgeuse is a red supergiant, meaning its outer layers are incredibly extended and unstable. Huge convection cells, each many times larger than Earth, bubble up from the star's interior, carrying heat and energy to the surface. These cells are so vast and dynamic that they can change the star's appearance over weeks or months. Normally, this restless activity causes only minor periodic fluctuations in Betelgeuse's brightness, subtle twinkles that astronomers have observed for centuries. But in late 2019, something extraordinary happened. The Great Dimming was different. Betelgeuse's light faded by more than 35%, a change visible even to the naked eye. Astronomers discovered that a giant plume of gas had erupted from deep inside the star, rising up and cooling a vast patch of Betelgeuse's surface. This event was far more dramatic than the usual surface turbulence. As this material was ejected into space, it cooled rapidly, allowing atoms to bond together and form dust, essentially creating a cosmic smokescreen that blocked the star's light. In the cold vacuum of space, these atoms clump into tiny grains of silicate dust. Over time, such dust becomes the raw material for new planets, moons, and even life itself. The dust cloud that formed was so thick and perfectly aligned with our line of sight from Earth that it dramatically dimmed Betelgeuse, making the star appear to fade away almost overnight. This wasn't a sign that Betelgeuse was about to explode in a supernova, but rather a symptom of its chaotic, turbulent old age, a phase all massive stars eventually reach. The true trigger for a supernova lies deep within the star's core, where nuclear reactions eventually run out of fuel. This process is invisible from the outside until the very last moment. The Great Dimming was a surface event, a dramatic reminder of the violent, unpredictable endgame for massive stars, and a glimpse into the cosmic processes that shape our universe. The scale of Betelgeuse's outburst was so extreme, it challenged everything we thought we knew about red supergiants. NASA's Hubble Space Telescope provided the breakthrough, capturing sharp images that revealed a dark patch forming on Betelgeuse's surface. Ground-based telescopes using interferometry confirmed the star's shape was distorted during the event. These images proved the dimming was caused by a massive dust cloud, not a drop in the star's energy. Without these visuals, scientists would have debated the cause for years. The combination of space and ground-based imaging gave us a 3D view of the drama. The images were the smoking gun, confirming a historic surface mass ejection. Betelgeuse's outburst became a visual testament to the violent forces at play in dying stars. The Great Dimming ended, but Betelgeuse's show continues. Its pulsations, once regular, are now erratic, with the star brightening and dimming at twice its previous rate. The massive eruption fundamentally altered the star's internal structure, leaving it in a state of ongoing instability. In 2024, another dimming event was observed, though less dramatic. Each fluctuation offers clues about the turmoil inside Betelgeuse, helping scientists refine their models. The star is still recovering, its interior sloshed by the colossal outburst. We're witnessing a star in its death throes, with every change offering a real-time look at the end of a giant's life. The final explosion may be millennia away, but the drama is unfolding now. When Betelgeuse finally dies, it will collapse in a fraction of a second, triggering a Type II supernova. The explosion will outshine every other star in the Milky Way, visible even in daylight for weeks. Imagine two moons in the sky, one our own, the other the ghost of a dying star. Despite the spectacle, Earth is safe. Betelgeuse is far outside the danger zone for harmful radiation. We'll witness the light show without any risk. The timing is unknown. It could happen tomorrow or 100,000 years from now. Because Betelgeuse is 500+ light-years away, the explosion's light is already on its way, or yet to begin. When it arrives, it will unite humanity in awe. The death of Betelgeuse will be a cosmic event for the ages. Betelgeuse's wild behavior has led to a bold new theory. It might have a hidden companion star. Dubbed Beetle Buddy, this smaller star could explain Betelgeuse's strange pulsations and long-term cycles. The companion's gravity might stir up Betelgeuse's outer layers, even triggering the Great Dimming. It could also help clear away dust, making Betelgeuse appear brighter than expected. Detecting Beetle Buddy is a challenge, like spotting a firefly next to a searchlight, but astronomers are hopeful, with new observation windows opening soon. If confirmed, Beetle Buddy would force a major rethink of how massive stars evolve. The search continues for this elusive cosmic partner. Betelgeuse's future explosion is safe for us, but supernovae are both creators and destroyers. Every heavy element in our bodies was forged in ancient supernovae, stardust that built planets and life. But a supernova too close can be catastrophic, stripping away our ozone and exposing life to deadly radiation. Studies link past mass extinctions to nearby stellar explosions, with evidence in Earth's rocks and fossils. Thankfully, Betelgeuse and other candidates are hundreds of light-years away, well outside the danger zone. We live in a fortunate era, able to watch these cosmic events with curiosity, not fear. Supernovae highlight the delicate balance that allows life to thrive. Our cosmic neighborhood is quiet, letting us marvel at the universe's power. The story of Betelgeuse reminds us of our deep connection to the stars. Betelgeuse is more than a future supernova, it's a living classroom. Every flicker and outburst tests our understanding of physics and the life cycles of stars. Studying it pushes technology and inspires global collaboration among scientists and amateurs alike. Betelgeuse connects us to cosmic timescales, reminding us of nature's vast power and our place in the universe. Its changing light is a message from centuries past, a glimpse into our cosmic future. Looking up at Betelgeuse sparks curiosity and wonder, inspiring questions about our origins and destiny. It's a gateway to scientific discovery, igniting a passion for exploration in people of all ages. In its turbulent final years, Betelgeuse is a beacon of knowledge and inspiration. It invites us to lift our gaze and contemplate the grand drama of the cosmos.